Local and remote file inclusion vulnerabilities. Let's first gain an understanding about file inclusion vulnerabilities. File inclusion vulnerabilities often affect web applications that rely on a scripting runtime and occur when an application allows users to submit input into files or upload files to the server. They are often found in poorly written applications. File inclusion vulnerabilities allow an attacker to read and sometimes execute files on the victim server, or as in the case with remote file inclusion, to execute code hosted on the attacker's machine. An attacker may use remote code execution to create a web shell on the server and use that web shell for website defacement. Moving on to the types of file inclusion vulnerabilities, there are two main types of file inclusion vulnerabilities: local file inclusion and remote file inclusion. Now let's begin with local file inclusion. Local file inclusion is an attack technique in which attackers trick a web application into running or exposing files on a web server. LFI attacks can require and expose sensitive information, and in severe cases they can lead to cross-site scripting and remote code execution attacks. LFI is listed as one of the OWASP top 10 web application vulnerabilities. A local file inclusion attack is used to trick the application into exposing or running files on the server. They allow attackers to execute arbitrary commands, or if the server is misconfigured and running with high privileges, to gain access to sensitive data. These attacks typically occur when an application uses the path to a file as input. If the application trusts that input as trusted, an attacker can use the local file in an include statement. While local file inclusion and remote file inclusion are similar, an attacker using LFI may include only local files. Next, we will gain an understanding about remote file inclusion (RFI). Remote file inclusion is an attack targeting vulnerabilities in web applications that dynamically reference external scripts. The perpetrator's goal is to exploit the referencing function in an application to upload malware, example backdoor shells, from a remote URL located within a different domain. An attacker who uses remote file inclusion targets web applications that dynamically reference external scripts. The attacker aims to exploit the target application's referencing function and upload malware from a remote URL based on a different domain. A successful RFI attack can result in information theft, a compromised server, and a site takeover, resulting in content modification. Moving on to the difference between RFI and local file inclusion and remote file inclusion are both security vulnerabilities that attackers can exploit to manipulate and execute arbitrary files on a web server. However, they differ in how they operate and the scope of the impact. Let's look at the key differences between LFI and RFI. Nature of vulnerability. LFI is a vulnerability that occurs when an application permits an attacker to include files that are already present on the server's file system. Attackers can traverse directories and they can access local files such as configuration files or system logs. It can further lead to potential information disclosure or even remote code execution in case the attacker can upload malicious files. RFI, on the other hand, is a web application vulnerability where an attacker can include remote files from an external server. It implies the attacker can execute code hosted on an external server, which can potentially lead to more server consequences. Attack vector. In case of LFI, an attacker usually manipulates user-provided input, for instance, file paths, in order to trick the application into including unintended local files. Whereas in case of RFI, the attacker injects a URL pointing to remote files, which are then fetched and executed by the vulnerable application. Scope of impact. LFI primarily affects the server where the application is hosted. It can lead to local data exposure and in some cases remote code execution if the application is not filtering user-supplied input. And RFIs can comparatively have a wider impact than other types of attacks because they can run code from a remote server. This means that an attacker could actually use an RFI to exploit a vulnerability in the system and execute arbitrary code, steal data, or even take complete control of the system. Now, exploitation complexity. LFI, usually exploiting LFI vulnerabilities, require a good understanding of the server's file system structure as well as the application's file inclusion mechanisms. Comparatively, LFI can be more challenging to exploit than RFI. RFI is easier to exploit since it relies on loading files from an external server, which the attacker controls. Defense mechanisms. LFI protecting against LFI vulnerabilities involves input validation, proper sanitization of user input, along with restricting file inclusion to only trusted directories. RFI defending against RFI involves preventing the inclusion of remote files altogether and filtering or validating user-provided URLs. Preventing local file inclusion vulnerabilities. ID assignation. Save your file paths in a secure database and give an ID for every single one. This way users can only see their ID without viewing or altering the course. Whitelisting. Use verified and secured whitelist files that ignore everything else. Use databases. Don't include files on a web server that can be compromised. Use a database instead. Better server instructions. Make the server send download headers automatically instead of executing files in a specified directory. Preventing remote file inclusion vulnerabilities. Proper input validation and sanitization must be implemented to minimize the risk of RFI attacks. Ensure you don't fall victim to the misconception that all user inputs can be fully sanitized. Look at the sanitization only as an additive to a dedicated security solution. Now sanitize the user supplied input or controlled input the best you can, including HTTP header values, URL parameters, cookie values, get post parameters. Check the input fields, and against a whitelist, an attacker can supply input in a different format, encoded or hexadecimal format, and bypass a blacklist. Client-side validation comes with reduced processing overhead, but they are vulnerable to attacks by proxy tools. So apply the warranty on the server end. Ensure you restrict execution permissions for the upload directories, maintain a whitelist of acceptable file types, and determine upload file sizes.